Lens. Lens is a transparent material which is bounded by two spherical refracting surface. So it is a lens which is made up of transparent material which is bounded by two spherical surface. It is one of the spherical surface. It is another spherical surface. It is called lens. Especially this is convex lens. So this convex lens is made up of a transparent material which is bounded by two spherical surface. This convex lens is also called biconvex lens because this material is bounded by, transparent material is bounded by two spherical transparent surface or two spherical refracting surface. That's why it is called convex lens is also called biconvex lens. And one more convex lens is there, that the transparent material which is bounded by one spherical surface and one plane surface. This convex lens is called planar convex lens. Next, another type of lens, concave lens. So concave lens which is made up of a transparent material which is bounded by two spherical surface. So it is one of the spherical surface, it is another spherical surface. So this concave lens is also called biconcave lens. Because this material is bounded by two spherical surface. That's why it is called biconcave lens. So one more type in concave lens, then the material, transparent material is bounded by one plane surface and another spherical surface. It is the planar concave lens. So concave lens is also called biconcave lens because this lens is bounded by two spherical surface, but planar concave lens, then the material, transparent material is bounded by one plane surface, one spherical surface. It is called planar concave lens. How we can differentiate convex lens and the concave lens? See, in the shape of convex lens, thicker at the middle, thinner at the edges. But in the case of concave lens, thinner at the middle, thicker at the edges. Convex lens is also called converging lens because when a parallel beam of light is made to incident on the convex lens, after refraction takes place, after refraction, the refracted rays are converged at a single point. That's why convex lens is also called converging lens, but the concave lens is also called diverging lens because when a parallel beam of light is made to illuminate on a concave lens, refraction takes place. After refraction, then the refracted rays appears to be diverged from a single point. That's why concave lens is also called diverging lens. Next, we are going to see the topic. What are the rules followed by the image formed by the thin lenses? First rule. The assumed one convex lens. Optic center of the convex lens, O, represented by the letter O. A straight line passing through the optic center through the two centers of curvature C1 and C2. Then, generally thin lenses has a two principal focus, F1 and F2. The distance between optic center and the centers of curvature is 2f1. Then the distance between optic center and the center of curvature is 2f2. In the first rule, when a ray of light is coming from the object travel which is parallel to the principal axis, strike a convex lens, refraction takes place inside the medium. So after refraction, then the refracted ray must be passing through the principal focus in the case of convex lens. This is the first rule. The same first rule is applicable in the case of concave lens. Optic center of concave lens, a straight line passing from the optic center through the two centers of curvature C1 and C2. Principal focus F1, F2. When a ray of light is coming from the object to travel parallel to the principal axis, strike a concave lens, refraction takes place. After refraction, see the refracted ray, direction of refracted ray travels along this direction. But this deep refracted ray appears to be diverged from a principal focus point. This is the first rule. In the first rule, in the case of convex lens, when a ray of light is coming from the object, travel parallel to the principal axis, strike a convex lens, refraction takes place. After refraction, then the refracted ray converges to the principal focus F2. In the case of concave lens, when a ray of light is coming from the object to travel parallel to the principal axis, strike a concave lens, refraction takes place. After refraction, see the refracted ray moves along this direction, but that refracted ray appears to be diverged from a principal focal point F1. Second rule. Rule 2. In the case of convex lens, optic center, it is a principal axis. There are two centers of curvature C1 and C2 due to two refracting spherical surface. There are two focal points F1 and F2. Focal point is also called the principal focus. When a ray of light is coming from the object, passing through the optic center, without any producing deviation, travels along a straight line. It is another rule. In the case of convex lens, a ray of light is passing through the optic center obliquely, then there is no refraction takes place and emerges out without producing any deviation in the case of convex lens. Then second, in the case of concave lens, optic center of concave lens, principal axis, there are two centers of curvature C1 and C2. There are two focal points F1 and F2. A ray of light is coming from the object, passing through the optic center, without producing any deviation, travels along a straight line. This is the second rule in the case of concave lens. Third rule. In the case of convex lens, optic center of convex lens O, principal axis, there are two center of curvature C1 and C2, there are two focal points F1 and F2. When a ray of light is coming from the object, passing through the principal focus, strike a convex lens, refraction takes place. After refraction, then the refracted ray travels parallel to the principal axis in the case of convex lens. So this is a ray of light coming from the object, passing through the principal focus in one side of the convex lens, strike a convex lens, refraction takes place due to tensor medium. So after refraction, then the refracted ray which is travel parallel to the principal axis in the case of convex lens. Then in the case of concave lens, optic center O, principal axis, there are two centers of curvature C1 and C2. There are two focal point F1 and F2. When a ray of light is coming from the object is directed towards the focal point, refraction takes place. After refraction, then the refracted ray which is traveling parallel to the principal axis. So this is a ray of light coming from the object which is directed towards the principal focus. So strike a concave lens. So refraction takes place. After refraction, then the refracted ray which is travel parallel to the principal axis is the third rule. Fourth rule, in the case of convex lens, optic center, principal axis, there are two centers of curvature C1 and C2 due to two radii of curvature of two refracting spherical surface. There are two focal points F1 and F2. When a ray of light is coming from the object, passing along the principal axis, passing through the optic center and without producing any deviation, travels along a straight line in the case of convex lens. In the case of concave lens, optic center of concave lens, principal axis, there are two centers of curvature C1 and C2. There are two focal points F1 and F2. When a ray of light is coming from the object, passing along the principal axis, travels along a straight line, passing through the optic center without producing any deviation coming from the lens in the case of concave lens. So, next topic, image formed by thin lenses. First we have taken one thin convex lens. When object is placed in front of the convex lens with a different position, image formed by the thin convex lens in other side or in the same side depending upon the position of the object is placed in front of the convex lens and also concave lens. So, image formed by the thin lenses is entirely depends upon the phenomenon of refraction of light. First we have taken thin convex lens. We are assuming one object is placed at an infinite distance in front of the convex lens. Rays coming from the object which is parallel, because object is placed infinite distance from the convex lens. Rays coming from the object is parallel beam. This is parallel beam of light is coming from the object placed at infinite distance, strikes a convex lens, refraction takes place. After refraction, then all refracted rays appears to be converged at a point on the principal axis. So these are the all refracted rays appears to be converged at a single point on the principal axis. This point on a principal axis is called principal focus. So this all refracted rays are intersect at this single point. Image will be seen. This image formed by the thin convex lens is entirely depends upon. Actually, all refracted rays are meet at this point. So image formed by this lens, when object is placed at infinity, the image formed by the thin lenses exactly at the principal focus. This image is real image because this image is formed due to actual intersection of refracted rays. That's why the image is a real image, and also point size image and also inverted image is the first case. Second, object is placed beyond 2f1. Let us consider convex lens, optic center of convex lens, principal axis 2f1, 2f2, 2f1 which is equal to center of curvature c1, 2f2 which is equal to center of curvature c2, principal focus f1, principal focus f2. Now, object is placed beyond 2f. AB is an object, is placed beyond 2f1. Rays coming from the object, one ray travel parallel to the principal axis, strike a convex lens, refraction takes place. After refraction, then the refracted ray must be passing through the principal focus f2. Another one ray passing through the optic center. This is another ray coming from the object, passing through the optic center without producing any deviation, travels along a straight. This is the first refracted ray, another refracted ray intersect at this point, image will be seen. So therefore, we draw a perpendicular line to this point from the principal axis. B prime, A prime. So A prime, B prime is the image formed by a thin convex lens. When object is placed beyond 2f1, image is obtained in between f2 and 2f2. That is the position of the image formed by the thin convex lens is f2 and 2f2. It is an inverted image. It is a real image. Real image due to actual intersection of two refracted rays. The image formed by the thin convex lens is a real image and also inverted image. When compare the size of the object and the size of the image is smaller than the size of the object. This is the second case. Then third position. Object is placed exactly at 2f1. Let us consider convex lens, optic center O, principal axis 2f1, 2f2, f1, f2. Now, object is exactly placed at 2f1 which is equal to center of curvature c1. AB is an object, is placed exactly at one side of the convex lens, placed at 2f1. One ray coming from the object which is travel parallel to the principal axis, strike a convex lens, refraction takes place. After refraction, which is travel through the principal focus. Then another one ray coming from the object, passing through the optic center without producing any deviation, travels along a straight line. When both the refracted rays are intersect at this point, image will be seen. So we draw a perpendicular line from this intersection point. This is image of an object. B prime, A prime. B prime, A prime is the image. AB is an object. So therefore, image formed by the thin convex lens, if its object is placed exactly 2f1, image is attained in other side of the convex lens is exactly 2f2. So it is an inverted image, real image formed by the thin convex lens in other side of the lens is due to actual intersection of two refracted rays. So compare the size of the object and the size of the image. So size of the image is the same size of the object. Object is placed between 2f1 and f1 in the case of convex lens. It is a convex lens, optic center, principal axis, 2f1 point, f1 point is f2 point, 2f2. So 2f1 which is equal to center of curve which is c1, 2f2 which is equal to center of curve which is c2. Now, object is placed in between 2f1 and f1. AB is an object is placed in between 2f1 and f1. Let me assume one ray of light is coming from the object to travel parallel to the principal axis, strike a convex lens, refraction takes place. After refraction, refracted ray travels up to the principal focus. Another one ray coming from the object passing through the optic center without producing any deviation travels along a straight line. Now, both the refracted rays, first ray and the second ray, both the refracted rays are intersect at this point, image will be seen. So, we draw a perpendicular line from this principal axis to this intersection point. That image B prime, A prime. It is an inverted image and also real image. Image is attained other side of the convex lens. Image is attained in beyond the 2f2 point. So it is an enlarged image. When compared to size of the image and the size of the object, size of the image is larger than that of size of the object. It is a real image, inverted image. Real image is entirely due to actual intersection of two refracted rays. Image is attained in other side of the lens beyond the 2f2 point. Next one question. Next position. Object is placed exactly at the principal focus f1 in the case of convex lens. Optic center, principal axis, 2f1 point, f1 point, f2 point, 2f2 point. 2f1 which is equal to center of curve which is c1, 2f2 which is equal to center of curve which is c2. Now, object is placed exactly at the focal point f1 in front of the convex lens. AB is an object is placed exactly at the focal point f1 in front of the convex lens. One ray coming from the object which is traveled parallel to the principal axis, strike a convex lens, refraction takes place. After refraction, it must be passing through the focal point f2. Another one ray coming from the object which is passing through the optic center without producing any deviation travels along a straight line. These two refracted rays are intersect at the infinity point. Image will be seen. So when object is placed in front of the convex lens is exactly at the principal focal point f1, image is attained in other side of the lens at infinite distance. It is a real image because this image is attained due to actual intersection of these two refracted rays. That's why the image is a real image and also inverted image. Image is attained exactly at infinity. It is a compare the size of the image and the size of the object. Size of the image is larger than that of size of the object. So in this case, image is attained is an enlarged image compared to the object. Next question. Object is placed in between F1 point and optic center. So let us consider convex lens, optic center O, principal axis to F1 point, F1, F2 point, to F2 point. Now, object is placed in between focal point F1 and optic center, focal point F1. Object is placed in between these two. AB is an object. One ray coming from the object which is traveled parallel to the principal axis is like a convex lens. Refraction takes place after refraction when the refracted ray must be passing through the focal point F2. Another one ray coming from the object passing through the optic center without producing any deviation travels along a straight line. These two refracted rays appears to be intersect in the same side of the object. Image will be seen in the same side of the object. It is one of the refracted ray. It is another refracted ray. Both the refracted rays appears to be intersect in the same side of the object at this point. Image will be seen. The perpendicular line is drawn from the principal axis to this intersection point. Image is A prime and B prime. Where compare the size of the image and the size of the object. Size of the image is very large compared to size of the object. It is a very enlarged image, and also image is attained in the same side of the object. AB is an object, A prime, B prime is the image. Image is attained is the same side of the object. It is a erect image. It is a virtual image. This image is formed by the thin lens in this case due to appears to be intersection of these two refracted rays. That's why this image is virtual image. So image is attained in the same side of the object. So this is the various case when object is placed in different position in front of the convex lens. Image is formed in other side of the lens. Image is formed in the same side of the lens. Depending upon the different position of the object is placed in front of the convex lens.